7 pi out of 6, 8 pi out of 6, 9 pi out of 6, 10 pi out of 6, 11 pi out of 6, 12 pi out of 6, which would bring us back to 2 pi. Okay? Are we good up to that part right there? Okay? What's up, brother? Alright. So that's the easy part. But it's hard. Because we just turned all those degrees into radians. Okay? So that's huge. But we have two triangles. We have this triangle. Alpha, alpha, and alpha square root 2. Okay? Then we have this triangle. Alpha, alpha square root 3, and 2 alpha. Right? These are our 30, 60, 90, 45, 45 triangles, correct? And what I'm trying to show you here is how we readjust these to fit into here. Now think, this is called a unit circle. And the reason why it's called a unit circle is because the radius of the circle is 1. 1 unit. 1 centimeter. 1 kilometer. 1 mile. Just one part of a distance. Does that make sense? Okay? So this radius is always 1. Okay? The radius is always 1. So that's the key. The unit means it's 1. Okay? What that means is all of these triangles that I'm going to make, right? Right? Okay? Okay. All of these triangles, these are all 30, 60, 90 triangles. Okay? And so I need to know these are all 45, 45 triangles, right? So I need to put this in terms of the unit. And if you look at the triangles, right? The hypotenuse to every triangle is the radius. Which is, yeah, you said 1, right? That means this is equal to 1. That means this is equal to 1. Okay? In order for that to be equal to 1, then I need to take this and divide by the square root of 2. So then alpha is equal to 1 over the square root of 2. But we can't have the square root in the bottom, right? So we bring the square root up and we leave back a ghost of what's inside. Right? So the square root of 2 over 2. Okay? Now that's what's alpha. So alpha is the square root of 2 over 2 and the square root of 2 over 2. In this case, alpha is different, right? Because 2 alpha equals 1. So I divide by 2. So alpha is equal to 1/2. Equals 1/2. And this, then that would be 1/2 times square root of 3. So you'd have square root of 3 over 2. Okay? And so that is your new numbers that you're going to be putting in for your triangles. And the reason why this is important isn't really for this. Okay? Because if we think about it, look at this one. This is 1. Okay, I'm going to put it in purple. This is 1, right? But this is the square root of 2 over 2, right? And this is the square root of 2 over 2, correct? Okay? And that means this length is the square root of 2 over 2, right? But as we come from here down, when we go down in the xy coordinate system, is it positive or negative?
Negative.
Yes. So now this becomes negative square root 2 over 2. See how that's different? The distance is still 1. And that's because, remember the distance formula we did in geometry, okay? It's the square root of a perfect square. Is a squared plus b squared equals c squared, right? So a squared plus b squared equals c squared. And it's always a positive number. Okay? Because it's a distance. So the hypotenuse is always 1. It's never negative 1. But the adjacent or opposite sides can turn negative. In this case, this is negative. In this case, when I'm looking at this triangle, this becomes negative square root 2 over 2, right? But this is the square root of 2 over 2 because it's positive. And yet, this is still 1. And when we go down, what happens? Now we have 2 negatives, right? This is still negative 2 square root 2. But this is also negative square root 2 divided by 2. Okay? And that's what's huge. This is what's hugely important for us to look at this angle, or this angle, or this angle, or this angle. Whether we're looking at 45 or 225. Right? Or negative 135. It's still going to have a reference angle of 45, right? And now we're referencing this angle to the opposite over the adjacent, if it was tangent. If it was sine, it's opposite over hypotenuse. If it was cosine, it's opposite, or it's adjacent over hypotenuse. Right? So let's look at this angle. So first of all, how do we do here? Does this make sense how we're setting this up?
Yeah.
Okay? So now we got to set this one up. This is the hard one. Okay? So this one has a lot of triangles in it. Right? So this one has the 30, 60, 90. Okay? Right here. So we have to look at this guy and go, okay, I see what's going on here. So I'm going to use red.